So, I heard you wanted to learn about guitars. This is a guitar. This is also a guitar. So, it's like 2 months later. I got a haircut. So, guitars are a bit of a bundle of different six-stringed things. This is an electric guitar, and it's a lot different than, your average. So, the difference between them is not actually all in its looks. They're very different. Sort of. I think. Hold on. Yeah, they're different. So, the physics behind guitars really is not that complex. The key takeaway from both of them is that the strings vibrate to create sound waves. According to Joe Wolf of the University of South Wales, the number of vibrations per second is called frequency. Frequency is measured in hertz. More vibrations per second will get you a high frequency, or a high pitch. Less vibrations per second will get you a low pitch, like a bass. You can change the frequency by detuning and retuning a guitar, which is changing the tension. You can do nearly the same thing when you put your finger on a fret. That will change the length. Now, if you look at the strings themselves, you'll see that they're all different kinds of thicknesses. Thicker strings have more mass, so they vibrate a whole lot slower. Slower vibration equals lower pitch. That's why bass strings are thick. Thinner strings vibrate faster, which is why they sound higher. If all of the strings were the same thickness, they'd sound all the same. And there's another part of that story. Acoustic guitars, dare I say that acoustic guitars are only louder because they're hollow? Acoustic guitars use what is known as resonance to project their sound across a room without the use of secondary objects. But what is resonance? Resonance is when something vibrates at its natural frequency, then gets amplified by the vibration of other things around it. The body of an acoustic guitar is made of wood. That's not random. Jonah Asteris of Liberty University stated that different wood types can be favored due to aesthetic, strength, and acoustic capability. This means that the projection of the sound of the guitar relies on the wood type. Now, like I was saying, the acoustic guitar uses resonance, which makes it loud. The electric guitar does not have this advantage. So, why does this happen? Long answer, the material of the strings. Short answer, it's not hooked up to one of these. Here, let's see if I can wake up my neighbors. So I'm hoping a few of you guys are like, oh, how does the electric guitar get to the amp? You see these little metal spheres on these larger ovals? Those are called pickups. What they do is they pick up the vibration of the strings. What are pickups exactly? Well, in the shortest terms I can think of, they are little magnets wrapped in a bunch of copper wire, which create a magnetic field, which when the strings vibrate, it disturbs them like crazy. That creates a tiny electrical current, which mimics the sound of the string vibrations. I'm pretty sure you can imagine what the amplifier does. Also, I think I'm gonna change the song. This is getting pretty old. For electric guitars, once the signal leaves the guitar and goes to the amp, you can actually reshape the sound itself. When you add distortion, you're actually clipping the sound wave. That makes the guitar sound more aggressive and powerful. This is clean, and this is distorted. Well, you made it to the end of the video. And honestly, I still haven't come up with a name yet, but I do have to say, it's been fun learning about guitars with you, Zane.